Hello, welcome to Math with Mr. Dobrescu to the rescue. Today we are going to solve system of linear equations by graphing. So take a look at the first example here. We have y equals negative x plus 3, and the second equation we have y equals 2x minus 6. Remember when we did graphing linear equations, we had to follow some steps. So similarly to graphing linear equations, when we graph system of linear equations and then find the solution, we are going to do similar steps. So step number one would be to get both equations into the y form. We want to make sure that y is by itself in both equations. So in this case, we have y by itself equals negative x plus 3. And the second equation, we also have the y by itself, y equals 2x minus 6. So the first step is already done because both equations are in the y form. Let's look at step number 2. Now we are going to label the m, the slope, and the b, y-intercept in both equations. Let's do that. But you also have to remember that if x does not have a number, we are going to put the invisible one in front of x. And remember, we need to have a fraction, rise over run. So let's put another 1 underneath here. And for the second equation, we are going to put a 1 under the 2 because we need a fraction for the slope. And let's label the m and the b in both equations. So let's label the m in the first equation, which is negative 1 over 1. That's our m. And our b is positive 3. And in the second equation, m is 2 over 1. That's our slope. And negative 6 is our b in the second equation. So step number 2 would be to label m and b in both equations. Step number 3, now we are going to graph both equations on the same graph. And remember, we are graphing b first because b stands for beginning. Remember that? We came up with that phrase. We grab the b first. We are going to grab the y-intercept first. Let's drop number 1 first. So we are going to go to positive 3, right? So we go 3 units up. 1, 2, 3. We draw a dot at positive 3. And then we are going to go 1 unit down because 1 is negative. So we go 1 unit down. And then the other unit to the right. So let's rise 1 unit down, and then the other unit to the right. And now we have the second dot. And let's connect the dots to get the first equation graphed. Okay, so that's the line for the first equation. Now let's take a look at the second equation. And we are going to graph b first, right, on the same graph. So now we are going to go to negative 6 because b is negative 6. So we have 1, 2, 3, 4, 5, and 6 right there. And then we are going to go 2 units up because 2 is positive, 2 up, and then another unit to the right. Rise over run. So let's go from 6 2 units up, 1, 2. And then another units to the right, and it's going to be right here. And now we are going to connect the dots. Let's connect the dots. And then, let's look at step number 4. The solution is the point where both lines intersect. Let's look for the point where both lines intersect. And the point is right here. And now, once we find the point, we are going to create the order pair of that point, the location of that point on the coordinate graph, right? We need to find the location. Remember, each location has an x coordinate and a y coordinate, right? We got to find the coordinates of that point so we can find the solution. Let's do that. So let's find the x for that point. Obviously, x is at positive 3. So the solution is, right, x is at positive 3, right? That's our x, right? And our y is 0, right? Y, if you go to the y from this point, y is 0. So our final answer, our solution for this system of equation is 3, 0. This is our answer. 3, 0 is the solution of this system of equation. And let's check to see if we are right. Remember, anytime we check something, we eventually are going to see if we get a true statement after we plug in 3 for x and 0 for y in both equations. And if we get the true statement, that means we got it right. We got the solution right. Let's plug it in. Let's plug 3, it's our x, right? And 0, it's our y. So let's go for the x. If we plug in for y 0, we have 0 equals, instead of x, we are going to put 3, but it's negative, right? So we have negative 3 plus 3, right? So obviously negative 3 plus 3, we get 0. 0 equals 0, and that's a true statement. That means it worked, the solution worked for the first equation. Let's check the second equation. I'm going to do the work right here. So instead of y, we are going to put 0, right? So we have 0 equals, instead of x, we are going to put 3, but they have 2 times 3. So we have 2 times 3, and then minus 6, right? So we have 0 equals 2 times 3 is 6, and 6 minus 6 is 0. So 0 equals 0, and then we get another true statement. So voila, that's it. We got the answer. 3, 0 is the solution of our system of equations. And remember, always remember to follow these steps. Remember, step number 1. Get both equations into the y form. Please make sure y is by itself in both equations. Then we are going to label the m and the b in both equations. Please remember that. And then we are going to graph both equations on the same graph, remembering we graph the b first because b stands for beginning, right? We graph b first and then the y. And finally, where the line intersect is our answer. We have an answer right there. This point is the solution of this system of equations. Okay? Let's look at another example now. Example 2. We have x minus y equals 2 and x plus y equals negative 6. And in this example, we see that the y is not by itself. So we need to do something to get rid of this x on both equations so we can get the y by itself first. Because we got to follow those steps. Remember, get first y by itself. We need to get both equations into the y form. Now, remember, we have to do, if a variable does not have a number, we are going to add the invisible 1 in front of that variable. And we also need it here because the y is negative. So we need that placeholder. We need to add a 1 in front of the y. On the second equation, we only need a 1 for the x because this y is positive. So we keep it the way it is. Okay? So now let's solve both equations for y so we can graph these equations. So let's do that. So on the first equation, we need to subtract 1x on both sides. Whatever we do to one side, we do to the other side, minus 1x. Because the equation was not in the y form, right? Let's see what we get. This cancels out, so we have negative 1y equals, we cannot combine those two together, right? But we need to put the slope first, so we have negative 1x plus 2. And in order for us to get the y by itself, we need to divide both sides by negative 1. So let's divide both sides by negative 1, negative 1, negative 1. And let's see what we get. Let me write the answer right here. So we get negative divided by negative becomes a positive y equals negative divided by negative. Remember, Dr. Triangle becomes a positive 1 over 1. We need to rise over run x. And then 2 divided by negative 2, we get negative 1. Actually, it's supposed to be negative 1 there. So let's change that because we divided by negative 1. negative 1, right? So 2 divided by negative 1 becomes negative 2. And we got the first equation in the y form. Y equals mx plus 2. Negative 2 is the y-intercept. Okay, let's get the second equation into the y form by subtracting 1x on both sides. Let's subtract 1x here and 1x on the other side. 1x and negative 1x cancel each other out. So we get y equals, and again, we cannot combine negative 1x and negative 6 because they are two different terms. So we need to keep negative 1x first, plus minus 6, right? And also we have to remember that we need to put a 1 under negative 1 because we need a rise over run. So let's label the m and the b in both equations and then graph the equations. So in the first equation, the m is 1 over 1. Remember the number, the fraction in front of the x, that's our m. And the y-intercept is negative 2, that's our b. And on the second equation, m is negative 1 over 1. And b is negative 6, that's our b. So we got both equations into the y form. We labeled the m and the b in both equations. And now let's graph both equations on the same graph, right? On the same coordinate plane. By graphing b first, because b stands for beginning, right? So let's do that. So the first one we have negative 2 for b, so we go 2 units down. So 1, 2. And then we go 1 unit up and 1 unit to the right, okay? Because 1 over 1 is positive. So 1 up and 1 to the right, and we get the second dot right there. And let's connect those dots. And that's our first line. Let's take a look at the second line now. Second line we have b is negative 6. So you go down 6 units. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we have 1 unit down because 1 is negative and 1 unit to the right. So 1 unit down and 1 unit to the right. Now let's connect those dots. Okay? Let's connect the dots. Oops. Gotta be careful here because not enough room here. My bad, sorry. Oh, let's get back. Okay, perfect. Something happened there. One more. Okay. Now let's go back here. Let's connect the dots. And remember, the solution is where the dots intersect, right there. Okay? So let's find this point. Let's find the location of that point because we know the solution is where both lines intersect. So we need to find the x for that point. So in order to find the x, we go up. So to go up, it's to find the x, so x is negative 2, right? And in order for us to find the y, we got to go to the y-axis from that point, which is negative 4. I'm not exactly perfect because I do not have a perfect coordinate graph, right? But I did the best I could, right? So the location of that point is negative 2. That's our x, right? You go up until you cross the x-axis from that point to find the location of that point, which is negative 2. And to find the location for y, you go to the right until you cross the y-axis, and we cross the y-axis at negative 4. And that's our answer. Negative 2, negative 4. And let's check. Let's check to see if we are right. So we are going to check the first equation. We have x minus y. So instead of x, we are going to put negative 2 for x. So we have negative 2 minus y. So minus, and y is negative 4. Negative 4 equals 2. And remember in our previous lesson, adding and subtracting integers, we remember that if we have two negatives next to each other, we do boom, boom, right? So those are going to become positive. So now we have negative 2 plus 4 equals 2. And negative 2 plus 4, we get 2. 2 equals 2. And that's a true statement, right? So we got it. So this solution satisfies the first equation. Let's see if the solution satisfies the second equation, if we get a true statement for the second equation. So instead of x, we are going to put negative 2. So we have negative 2 plus y. So y is negative 4. So we have plus negative 4 equals negative 6. And obviously, the same thing, negative 2 plus negative 4, just like adding and subtracting integers. Remember, same signs, right? Add, we are going to add the numbers and keep the sign. Negative 2 plus negative 4, we get negative 6. Negative 6 equals negative 6. And this is a true statement. So we can say with certainty that negative 2 and negative 4 is the answer, is the solution for our system of equations, because it's the point where both lines intersected, right? They intersected at that point. And that location of that point is negative 2, 4, negative 4, and that's the answer, that's the solution for our system of equations. One more example. Let's look at example number 3. Okay? The same thing in this example, we see that y is not by itself. And remember, our job is to make sure that we get the y by itself. So in this case, we are going to subtract 1x on both sides. Whatever we do to one side, we do to the other side, minus 1x. Because we want to cancel that. 1x minus 1x cancel each other out. So we are left over with y. That's what we wanted. Y to be by itself. And then we get negative 1x minus 2. And now you already know by now that we got to put a 1 under the negative 1 because we need to have the slope, the m, right? The m has to have a rise over a run. And negative 2, of course, is our b. So we are done with the first equation. We got it in the y form, and we also labeled the m, the slope, and the y-intercept b in that equation. Now let's take a look at the second equation. We have 7x minus 4y equals 8, right? So in order for us to get the y by itself, we need to subtract 7x first from both sides. So let's subtract 7x on both sides. 7x minus 7x cancel out, right? So we have negative 4y equals, and again, we are going to put the negative 7x first, right? Negative 7x, and then plus 8. And finally, in order for us to get the y by itself, we need to get rid of the negative 4, right? And opposite of multiplication is division. So let's divide both sides by negative 4. And then negative divided by negative becomes a positive. So we get y by itself equals, the same here. Negative divided by negative becomes positive 7 over 4. X and 8 divided by negative 4. That's the triangle. Positive divided by negative becomes a negative. And 8 divided by 4 is 2. And now we are going to label the m and the b. So the m is 7 over 4. That's our m. And the b is negative 2. That's our b. And now, the final step would be to graph both equations on the same graph and find the answer, right? Let's graph the first one. Remember, we graph, of course, we graph b first because Mr. Dobrescu said b stands for beginning, right? You remember that, right? Negative 4, negative 2, right? So we go to negative 2 for the b. 2 units down. Let me use another color. 2 units down, right? From 0, 1, 2. And then we go 1 unit down because that's negative. And then 1 unit to the right. So let's rise 1 unit down. So 1 down and then 1 unit to the right. And then we got the second dot. Finally, let's connect the dots for the first equation. And now let's graph the second equation. So we graph B. Again, B, it's -2. So the points overlap. So B is right here, -2. And then we go 7 units up because 7 is positive. And 4 units to the right because 4 is positive. So let's go 7 up from there. 1, 2, 3, 4, 5, 6, 7. And then 4 units to the right. So we have 1, 2, 3, 4. And then we do another dot there. Right? And finally, we are going to connect the dots. Let's connect the dots. And we see that both lines intersect at that -2, right? This -2, both lines intersect at -2, right? But that -2 is our y-intercept, right? It's not the x, it's the b, right? The y-intercept. So now the x for that point, x is 0, right? That's our x-axis, that's y-axis. So x is 0. So the final answer, we have 0 for x and -2 for y. That's our x and that's our y. That's the location, that's the destination, that's where the lines intersect. And that's our solution of this system of equations. And now let's check to make sure that this solution is actually satisfied both equations and we get true statements. Otherwise, that's not the solution, right? So let's go. The first one, we have x. Instead of x, we are going to replace with 0. So we have 0 plus y. So plus y is -2. -2 equals -2. And we know that 0 plus -2 becomes -2. -2 equals -2. And in fact, that's a true statement, right? So that's true. So we got it for the first equation. Let's check for the second equation to see if we get the true statement for the second equation. So let's plug in 0 for x. So we have 7 times 0. And then minus 4 times y. But y is -2. And then equals 8. Right? We know that any number times 0 is 0. So that goes away, right? We get 0. And then negative times a negative, that's the triangle. Remember, we learned that in the previous video. Negative times a negative becomes a positive, right? 4 times 2 is 8. 8 equals 8. And again, we get another true statement, which tells us that 0 and -2 is in fact the solution of this system of equations. Okay? It was not very difficult. Remember, we use the same steps just like we did when we graphed linear equations, right? But now we graph system of equations, but the same step. Get both equations into the y form. We have to do that. We want to make sure that both equations, we get the y by itself, right? Y has to be by itself. Then we are going to label the m and the b in both equations. And then we are going to graph both equations, graphing b first and then m, on the same coordinate graph, the same coordinate system, right? And our solution, remember, is where the lines intersect. That's our solution. Remember that, where the lines intersect is our solution. Okay? Again, don't forget to like and subscribe. Mr. Dobrescu needs all your likes and subscriptions, and watch these videos several times. Okay? And share it with your family and friends. We want to make sure everyone is confident and is like solid and they know how to graph system of equations following this easy step by step. All the best to you. Goodbye. Take care. And remember, practice, perfect practice makes perfect. Take care.